I'm Isidore.
And I'm Zach.
And this is our Intro to Embedded Systems Fall 2025 final project, Team 20. Here's a clean build of our project. Build finished. Our only warning is related to the SDK.
For level 0, we will be using pulse width modulation to play a song on our BoosterPack buzzer. Our song will start with push button 1, stop with push button 2, and restart with push button 1. And we will display the current note being played in the song on our LCD screen.
For level 1, our idea was to display the staff with the treble clef on it and then have notes move up and down to their proper position and change shape to represent the duration of that note. And then for level 2, we wanted to read input from the joystick. There's a push button, it moves in the X direction and it moves in the Y direction. And we wanted to use all these inputs. So our goal was to modify the song playback in some way using all 3 axes of the joystick. Now I'm going to demo our project. I'm hitting the reset button. This is our start screen right here. When S1 is pressed, the song starts playing and the note is right there. And then when you press S2, it stops, and when it's in the pause state, it says pause, and the note is continued to display right here on the staff. To restart the song, press S1 again. And now for our level 1 extra feature, here's our animation. Our idea was to make the notes appear on the staff and move up and down as they start playing, and we put the treble clef right there as well. For level 2, we use the joystick. So moving the joystick up, this pitches us up an octave. Moving it down pitches us down an octave. Moving it right speeds us up from 120 beats per minute to 220 beats per minute. And then to the left, slows it down to 60 beats per minute. And then any combination of those works. So here you can speed it up, pitch it up. And here you can slow it down and pitch it down. And when you press on the joystick, it restarts the song from the beginning.
Now we'll go over the pictorial description of our project. Once we start our main.c, we initialize our timers. We're using A1, G12, our LCD, our push buttons, and our booster pack. Then we enter our infinite loop, and that's where we stay for the rest of our functionality for levels 0, 1, and 2. Next, we'll go over our main functions, which are update FSM, display note, and play note. Here's the logic for our update FSM function. For level 0, we have 2 decisions to make, whether switch 1 is pressed or if switch 2 is pressed. If switch 1 is pressed, then we change our current state to play. If switch 2 is pressed, we change our current state to pause. In the same function, we also have our joystick inputs, which is a switch when you press down on the joystick. If the joystick switch is pressed, then the song will restart just by setting the index to 0. For our joystick position, the joystick outputs an XY coordinate, and we have to set ranges for each of these settings such that when the Y is crossed or when the X is crossed, the state changes to its respective quadrant. Our display note function uses a bunch of switch case structures to break down our duration array and our melody array into the useful information that we need. For our melody, we manually classified each note name into a string, and so the switch case picks that note and displays it for that string. We also manually classified the E's into their own group, such that the Y-axis is shared for all E's, because we don't display octave outside of our string name. For duration and melody, we get both the note length and depending on this y-axis, we also get from melody if the note needs to be flipped on the staff or not. So these are all drawn, both the level 0 and then both of our level 1 animations are drawn on top of our base image and sent to the LCD one at a time, and then the process is repeated for the next note. The play note function is our level 0 functionality, where we start, if the state is paused, then we just set the PWM duty cycle to 0, which sets our tone to 0. So technically the PWM is running, but no sound is playing, so we're in pause. And we just loop. If we are not in pause, then we start playing our next note. If our note is a rest, we set the PWM period to 0 manually instead of doing our PWM calculation, which divides by whatever the note frequency is, and we don't want to divide by 0. We right shift our PWM duty cycle to get 50%, and then we check our note length and set our time delay timer, and then we index. If it's the last note, we will reset to 0. If it is not the last note, we just go to the next note, and then we go back to main.